All right, we're going to continue on in Unit 5 with characteristics of parabolas. So coming into this class, you've probably seen a parabola before, or you may have even worked with graphing them with an XY table. We're going to go just a little bit more in depth today and look at some specific characteristics that every parabola has. And that's the axis of symmetry, the maximum minimum value, the vertex, and x and y intercepts. Okay, now some parabolas don't have x-intercepts, and we'll talk about that in a minute. But these are all things that we should be able to identify on any and all parabolas. Okay, so let's look at this one. And I'm going to kind of just highlight some stuff as I'm talking about it. Okay, so the first thing is the axis of symmetry. Okay, and the axis of symmetry is basically the line that splits the parabola down the middle, or the line that reflects the parabola about itself. So we're going to just say the line that splits the parabola in half. Okay, or down the middle. Okay, now a couple of things about this is I said it's the line, right? So if it's a line, it needs to be written as a line. So I want to show you where that is. Notice we have symmetry with parabolas, right? This side looks like this side. So if I were to split this right down the middle and just make a line here, right? This line splits it right down the middle so that the left side looks just like the right side, okay? So that's how we find our axis of symmetry. Okay, this is our axis of symmetry. Okay, and because it's a vertical line, remember the way that we write vertical lines is x is equal to some number, right? So for our example here, it would be x equals 1. Okay, it would be x equals 1 because this is the line x equals 1 that splits us right down the middle. Okay, so this is always going to look like x equals some number, and I'm going to call it h. And you'll see why I call it H here in a minute, okay? But it's always going to be a vertical line, x equals whatever that number is that's right down the middle of the parabola, okay? The next thing I want to look at is the maximum or minimum value, okay? Now, maximum and minimum value is the highest defined point or the lowest defined point on the parabola, okay? So I'm just going to say the highest or lowest point on the parabola. Okay, and it really depends on if it's the highest or lowest, whether or not the parabola opens up or whether it opens down. Okay, so if we have a parabola that opens downward, then this highest point is going to give us our maximum value. Okay, if we have a parabola that opens upward, then we're going to get a minimum value, right? Because it's going to be at the base of the U of the parabola, right? So this gives us a minimum, okay? And that minimum value is always a y value. Now, some softwares and textbooks will write it as the ordered pair, so you could write it as that point, but if they actually ask you for that minimum value, it's a y value, okay? So because it says highest point on the parabola. So we look at this one, this is the highest point on this parabola, so we have a maximum. So for our example, we have a maximum, and that maximum y value is at 4. Okay, so this would be y equals 4. Okay, so it's always going to be a y value, and I'm going to call that y value k, and you'll see why here in just a second. Okay, so we've talked about the line that splits it down the middle, which is always going to be x equals some number, right? And we talked about that highest point, right? This is our maximum value. Okay, now the most important point that will help us determine these two things without having to look at a picture is our vertex. And the vertex is basically the center point of the parabola. The center point of the parabola. Okay, so when we look at our parabola, this would be our center point, right? Actually, it happens to be our maximum point, right? So if we know what this center point is, which we're going to call this is our vertex, and we're going to call it HK. We always denote that point as HK. I don't know why, I don't know who picked the letters, but that's what we call it, okay? So once we know what that point is, notice if this point is HK, then this axis of symmetry is always going to be x equals that x value of my vertex, right? Which is h. So that's why we wrote that here, okay? And then our maximum or minimum point will always be the y value of our vertex, right? And the y value of our vertex will always be k. So that's why we wrote as our max or minimum point y equals k. So really, if you know the vertex of your parabola, without even looking at a picture, you should be able to tell me what the axis of symmetry is and what the max or min value is, right? Because it's just the x and y values from that vertex, or the h and k values rather, okay? And then the last thing that we identify on a parabola is our x and y intercepts. Okay, and these are just points where the parabola touches or crosses the x or y axis. Okay, x-intercept, y-intercept are just the points where the parabola touches or crosses the x or y axis. Okay, and we always write them as ordered pairs. Always, because they represent a point on the graph. Oh, speaking of point on the graph, we forgot to write our vertex. So using this example up here, because I actually have numbers, for our example, if we want to find this vertex point, notice this is at the point 1, 4. Forgot to put that on here. 1, 4. Okay, so notice once we know our vertex is 1, 4, we can see our axis of symmetry is going to be x equals 1. Our maximum point is y equals 4. Okay, so all of these are super related, right? Okay, and then we look for our x and y intercepts. So we can see on the x-axis, right at this point at 3, and also over here at -1, these are x-intercepts, right? Because it's where it touches or crosses the x-axis. Okay, so we can go ahead and say for our example, we have x-intercepts, and remember we write them as ordered pairs, so don't just say -1 and 3. This would be -1, 0, 3, 0, and then we look for a y-intercept, and a y-intercept is where it touches or crosses the y-axis, and every parabola has a y-intercept. Not everyone has an x-intercept, right? Because we could have a parabola that's below the x-axis that's pointing down, so it's never going to touch it, or we can have a parabola that's above the x-axis that's never going to come down and cross that line, right? But it will always cross the y. So if we look at this one, we can see this one crosses our y-axis at +3, so that's our y-intercept, and we want to write it as an ordered pair, so that would be the point 0, 3. Oops, pencil broke. Okay, so these are all the characteristics that we are going to look at identifying. So on the next page, there are 2 for you to try. So all I want you to do is identify the vertex. From that, you should be able to tell the axis of symmetry and the max or min value. Make sure you identify if it's a maximum or a minimum value, and then state your x and y intercepts, if there's any, as ordered pairs. Okay, so go ahead and pause the video, and I'll give you a minute to work it, and when you're ready to check yourself, go ahead and unpause the video and we'll see how you did. All right, so we're going to go ahead and look at the practice problems. So you can see here our lowest value, or our center point of this parabola, or our vertex, is at the point -5, -3. Okay, once we know that vertex point, we can see that the line that cuts this down the middle is going to be x equals -5, right? Which also -5 is the x value of our vertex, right? We have a minimum value because it's down here at the bottom of our parabola, and that lowest y value here is at -3. Okay, so we circled it's a minimum, and our lowest y value is -3. Again, it may have you enter this as the ordered pair as the vertex, but I want you to get used to writing it as that minimum y value. Okay, and then we look for our intercepts. It crosses at negative. Well, I thought that was -7, but it doesn't look like it was supposed to be at -7. This is not a good example. I might need to fix that. Sorry about that. Well, it should land nicely on a point. This should have been at negative. I don't know what it was supposed to be. We'll say we're going to approximate this one, okay? This was a bad example. I apologize. So this is going to be at -6 and not quite a half. So let's say -6.25, right? Because that's about -6 1/4. And then this one, we're just going to approximate and say it's -4. I apologize for that not being printed nice and pretty for you. So the ones that you do in your homework when you identify these should come out to nice, pretty intercepts. So I apologize. And then the y-intercept, notice this is going to have a y-intercept because this is going to keep going and eventually cross the y-axis. But for the sake of this example, it's not shown. So it does exist. So don't put that there's not one. But I just wrote on here that it's not shown. We're not going to be able to see it on our graph. Okay. If it asks you to identify the y-intercept on your homework, though, it will be one that obviously you can clearly see from the picture. Okay, let's look at number 2. Hopefully we don't have issues on number 2. All right, so number 2, again, we look at our center point, which here is also going to be a minimum value, right? That lowest point on this parabola that's in the dead center is going to be our vertex, which is the point 2, 3, right? So we can see our axis of symmetry is going to be x equals 2, that vertical line, right? And then we have a minimum, again, minimum value because it's the lowest point on the parabola because it's opening upward, and that minimum y value is at 3. Now here we can clearly say that there's not going to be any x-intercepts because this is a parabola opening upward. These lines are never going to magically curl back around and come hit the x-axis, right? So there's no x-intercepts for this parabola, but there is a y-intercept. There's always a y-intercept, and we can see here clearly that it's going to cross at 7. So we write that as an ordered pair 0, 7. Okay? All right, so this, that's pretty much all of the characteristics, just being able to identify the axis of symmetry, the maximum or minimum value, identifying the vertex, and finding those intercepts. Okay, so those are all the characteristics we're going to use in this section. It's really just identifying them. In the next section, we're going to learn how to actually solve for these, right, if we're not given a picture. So you should be able to finish the characteristics of parabolas assignment in Newton. And if you have any questions, please let me know.